low carbon fuel are essential, but fuel alone are not enough. And even the cleanest vessel cannot operate sustainably without the right infrastructure onshore. And this brings us to pillar 2 of the decarbonization pathway, strategic infrastructure development. And port are more than passive interface between sea and land. They are critical enabler in the energy transitions, determining which fuel can be supplied, how efficiently vessel operate, and how quickly emissions can be reduced across the value chain. And in this chapter, we shift our focus from what power ships and to how port must evolve. And this includes the investment in electrifications, shore power, green bunkering facilities, and internodal connectivity, all designed to support next generation's vessel while cutting emissions within the port boundary. And what I'm trying to say here, the message is port that invest early in a green infrastructure will shape future trade route and attract premium low carbon fleet and secure long-term competitiveness. So let us now look at how the strategic infrastructure can turn decarbonization goal into operationally reality. When we talk about strategic infrastructure, it is important to recognize that many leading ports around the world are already moving decisively in these directions. Globally, frontrunner ports have committed to ambitious emission reduction target, up to 45% by 2030, in line with international climate agreement and national decarbonization roadmap. What is particularly encouraging is that significant progress has been achieved, with some port recording close to 30% reductions of early as 2021. Largely through electrifications and operational efficiency. And these ports are not acting in isolations. They are positioning themselves as a regional green hub, capable supplying alternative fuel, supporting next generation vessel, and anchoring green shipping corridors. International collaborations such as infrastructure and climate partnerships are playing the key role in accelerating these transformations. What distinguish this leading port is not just technology, but the strategic intent. They are investing early based on their locations, cargo volumes, and long-term trade relevant, ensuring they remain competitive, and shipping lines increasingly prioritize low carbon routes and green certified port. The takeaway from this slide, clearly, port and act early do not just reduce emissions. They gain strategic advantage. By investing now, port can future-proof their infrastructure, attracting a premium fleet and establishing themselves as indispensable node in decarbonization's global maritime network. Yeah, having seen how leading port are setting ambitious target and positioning themselves as a green hub, the next questions for port authorities and policymaker is where the prioritized actions for immediate impact. So what I can say here, electrification is one of the fastest, most proven levers available to port today within their own boundary. Unlike fuel that depend on fleet renewable cycle, electrification can be deployed directly from from the port operators will with clear governance and accountability and reporting benefit. The key starting point is a cargo handling equipment, replacing diesel-powered RGT crane with electric gantry crane, deliver immediate of verifiable carbon reductions, while also improving operations reliability and reducing local air pollutant. Similarly, electric prime mover for yard operation example are now being tested and deployed, reducing fuel consumptions and improving air quality across terminal areas. A priority concern for port located near urban center. On the marine side, hybrid and electric tug and pilot boat address one of the most fuel intensive phases of port operating, vessel maneuvering, delivering both emissions and fuel saving. And to ensure this investment deliver full decarbonization benefit, port are increasingly integrating on-site renewable energy generations. Like I said, rooftop solar, BESS example, battery energy storage system, such as solar, wind, and as I said just now, battery storage. This allow electrified port equipment to be powered by clean energy rather than simply shifting emission upstream. For policymaker, the implications is clear. Electrification is not experimental. It is deployable for port authorities. It represents a concrete pathway to meet 2030 target and improve environment performance and demonstrate leaderships in maritime transitions. Now, electrifications deliver immediate emissions reduction, but to unlock a full values of port must also become smarter in how they plan, operate, and govern the asset. This brings us to concept of smart port, where digital infrastructure is used to not only to improve efficiency, but to embed sustainability into day-to-day operations and long-term decisions making. Leading port are now deploy digital twin, virtual replicates a port of infrastructure and operations, and gain real-time visibility over energy use, equipment performance, and vessel and truck movement, and port authorities. This enable evidence-based policy, decision scenarios, planning, and transparent performance monitoring. Through digital optimization, port can reduce fuel burn and emissions by optimizing routes, minimizing idle time, improving berth and yard utilizations, all without expend for port land constraint or urban proximity pressure. And digital tool also transform asset management, predictive maintenance driven by real-time data, reduce unplanned downtime, expand asset facilities timeline, including improving some environmental and financial performance. And in short, smart port are not just more efficient, they are more governable, more transparent, more resilient, and position port authorities to meet 2030 target while supporting long-term national decarbonization strategy. Now, in smart port, provide the intelligent, the green operations, yeah, uh, the next step is to translate that capability into deliberate long-term infrastructure choice. So the way forward of a strategic infrastructure is therefore about prioritizations and sequencing, ensuring the public and private investment directly support decarbonization's outcome while preserving the port competitiveness. First, port must expand green bunkering capabilities. Developing methanol, ammonia, and hydrogen-ready bunkering infrastructure at selected hub port is essential to support next generation vessel fleet and emerging green corridors. And for policymakers, this required a clear setting strategy and a safety framework and coordination with the national energy planner. Second, port electrification must be scaled systematically. Investment in electric crane, yard equipment, and on-port transport should move from pilot projects to mainstream deployment, and supported by grid upgraded example from one places to evacuate electron and renewable energy integrations. And third, shore to ship power infrastructure should be treated as a priority policy instrument by enabling vessel to switch off auxiliary engine while at berth. Shore power deliver immediate emissions and air quality benefit. So particularly the port located near high population center. And finally, infrastructure planning must extend beyond the port gate. Internodal connectivity, especially improve rail and multinational link as a critical to reduce last mile emissions and lowering the overall carbon footprint from of port hinterland logic change. This is an example, one country to one country, across the country. Rather use port, maybe train system is much better, where you have a centralized port on land and using train as well as a systems to move the containers from one central to port example. So taken together, these actions reinforce a central message to a pillar two. Strategic infrastructure investment is not just an environmental obligation, it is a competitiveness strategy. And port that align infrastructure decision today with decarbonization's objective will the best positions to meet 2030 target and attract green shipping demand and anchor sustainable trade in decade ahead.